At 5:41 local time, the first sonar ping returns with something that feels off. Not weak, not fading, off. Inside the Combat Information Center, an operator leans closer to his screen as a crisp metallic echo flashes along the lower edge of the display. It is too clean to be stone, too motionless to be old wreckage, and far too intentional for a shipping lane this tight. 12 seconds later, another contact appears. Then another. Same depth range, same spacing, same silence. On the bridge, the command comes calmly, and somehow that makes it worse. Reduce speed to 5 knots. Beneath the watch team, the deck seems to shift in tone as the ship slowly gives away its momentum. Outside, the water lies flat in a gray-blue sheet, almost calm enough to look innocent. No haze on the horizon, no small craft racing across the surface, no aircraft overhead, just open sea, and one American destroyer suddenly moving as if the water beneath it has become a threat. Back in CIC, the sonar supervisor marks the contacts and calls for a fresh sweep. The display answers with more metal. One line of returns becomes 2, then 3. This is not random clutter, not drifting debris. These are fixed shapes below the keel line, each one placed with the kind of spacing nature does not create by accident. A mine warfare officer is already crossing the compartment before anyone says it aloud. Then he does. Possible minefield. No one repeats it. No one has to. The tactical screen updates. Red contacts begin appearing along the ship's projected path. The navigator recalculates usable water in real time, but the route keeps tightening. 500 yards of uncertainty becomes 300, then even less. Helm, steady up. Hold this course. The captain does not raise his voice. He does not need to. Everyone in the room understands the problem at once. A destroyer can answer aircraft, submarines, long-range weapons, and surface threats. But underwater mines do not need speed, courage, or warning. They simply wait, letting steel come to them. At 0544, the ship's embarked MH-60 is ordered into immediate launch. On the flight deck, the helicopter crew moves fast through rotor wash and salt spray as tie-downs come free. The blades begin to turn, slicing through the morning air with a hard mechanical howl. Below them, sailors secure every loose item on deck, while the destroyer holds just above steerageway. No one wants extra vibration. No one wants sudden thrust. Not now. In CIC, the sonar team widens the search arc, and the picture gets worse. Contacts now stretch off the port bow and the starboard quarter, far enough to rule out a small isolated patch. Whatever lies beneath the surface is broad, layered, and organized. One operator overlays the contacts against the shape of the channel. Another pulls up depth data. Slowly, the pattern begins to form, and the room grows quiet. There is a gap ahead. A narrow one. Too narrow. Captain, the mine warfare officer says, eyes fixed on the screen. That lane looks deliberate. The MH-60 lifts off at 0547 and banks low over the water, staying clear of the ship's disturbed wake. Its sensors begin feeding live imagery back into CIC. From above, the sea gives away almost nothing. A few faint color changes. A few subtle surface disturbances where the current bends around something hidden below. Not enough for an untrained eye to notice. More than enough for sailors trained to distrust calm water. Then the unmanned surface craft is brought online. It is lowered carefully, almost gently, into the water and sent ahead like a forward scout. Its mission is simple. Go where the destroyer cannot afford to guess. Behind the lead ship, the rest of the American formation begins to stack up. Distances open, compress, and open again as each captain fights the same dilemma. Stay too close, and one underwater event could affect more than one hull. Spread too far, and the formation starts to lose cohesion in restricted water. Over encrypted circuits, the reports remain short and controlled. No visual contacts on the surface. Maintaining separation. Standing by for revised track. At 0551, the drone's forward sonar confirms the first object. Rounded shape, moored, metallic, consistent with a naval mine, then another, and another. Not one object, not even one simple field. Multiple belts. Some appear anchored high enough to threaten a deep hull. Others sit lower, likely designed to react to pressure, sound, or magnetic signature. This is not crude placement. This is engineering. Someone studied how American ships move through confined water, then built the layout around that movement. The captain studies the tactical plot for 3 seconds, maybe 4. Stop thinking of it as scattered equipment, he says. Map the design. That changes everything. The officers stop looking for isolated danger and start looking for intent. The moment they do, the minefield begins to explain itself. Dense clusters on both flanks, a tempting corridor through the center. Choke points placed exactly where a large ship would have the least room to turn. The water ahead is not truly safe. It is only safer than the alternative. Not a wall, a trap. At 0554, the mine warfare officer says the line no one in the room wants to hear. This was not placed to stop the first ship. It was placed to guide the whole formation. No one answers. Outside, the destroyer keeps moving at 5 knots. A billion-dollar warship easing through the morning light as if one wrong heartbeat could change everything beneath it. Above, the helicopter circles. The drone moves ahead. Every screen on board now shows the same truth in a different color. The U.S. Navy has not drifted into underwater disorder. It has sailed directly into a plan. At 05:55 local time, the corridor begins to close. The destroyer is still moving at 5 knots, just enough to keep control of the rudder, but the illusion of open water is gone. In CIC, the tactical plot has changed from scattered red contacts into something far more unsettling. Structure. The shapes below no longer look random. They look connected. Arranged to guide, arranged to narrow the options, arranged to decide where a steel hull is allowed to pass and where it is not. The unmanned surface craft pushes another 300 yards ahead of the bow and sends back a sharper picture. Its sonar traces a line of moored objects curving across the starboard side. Even spacing. Careful placement. Each one positioned to push a vessel away from deeper water and back toward the center. The port side looks worse. There, the returns sit in dense pockets, slightly staggered, creating the kind of uncertainty no captain can comfortably solve on a chart. One officer says what the entire compartment is already thinking. They mind the turn. That is the first moment the field stops looking like a simple danger zone and starts looking like a map. On the bridge, the captain receives the update without changing expression. Ahead is a maze. A narrow opening still exists, at least in theory, but every new sonar pass cuts the margins thinner. Behind them, the rest of the formation is stacking up at cautious intervals. Ships built to defend themselves against advanced aerial and surface threats are now being held in place by objects that cost a fraction of a single defensive round. At 05:58, the MH-60 drops lower. From 200 feet, the helicopter crew scans the waterline with thermal imaging and high-resolution optics. Not because mines are easy to see from above, but because anything connected to them might be. Surface markers, disturbed current, small support craft, traces left behind during deployment, anything. The helicopter's sensor operator pauses on a pattern just off the port quarter of the lead ship. 3 faint irregularities on the surface. Not buoys, not natural chop. 2 fixed, 2 aligned. He tags them and sends the coordinates down. Seconds later, the drone confirms submerged metallic shapes directly beneath them. Now the lane ahead looks even tighter. At 06:01, the first clearance attempt begins. A remotely operated package is guided forward along the edge of the presumed safe corridor. There is no dramatic countdown, no raised voices, just a handful of sailors in a dim compartment watching a live feed as a small machine moves toward an object meant to stop a warship in its path. The package is set. The drone backs away. 3 seconds later, the sea jumps. The surge is short, hard, and violent-looking, but contained. A white column of water rises into the air, then falls back into the gray surface with a heavy slap. On the bridge, everyone watches the plume collapse. In CIC, they watch something more important. The shock reveals more mines. The pressure wave clears uncertainty from the sonar picture. Hidden contacts appear behind the first line, then beneath it, then offset toward the flank. What looked like a single forward point is actually the outer edge of a layered belt. The mine warfare officer zooms out, runs a new estimate, and says it quietly. This field runs deep. No one asks how deep. The answer begins appearing on its own as more overlays stack across the tactical plot. Contact counts climb quickly, then faster. Dozens become hundreds. Hundreds become a projection too large to stay comfortably in a room full of professionals. This is not a small denial patch. Not a rushed obstacle placed from a few small boats. This is a prepared underwater battle space. By 06:05, the lead destroyer is no longer the only ship at risk. The whole formation is now part of the problem. A cruiser farther back reports reduced maneuvering room. Another destroyer signals that wake interaction is beginning to complicate station keeping. They cannot spread too wide without entering water that has not been cleared. They cannot close in too tightly without turning the column into a compressed line of targets. The geometry is doing exactly what it was designed to do. The field is not just stopping movement, it is controlling behavior. Then electronic warfare catches something new. A short burst, narrow band, surface level source. Near the outer edge of the mine belt, a small contact flickers onto the long-range camera feed. It is too far away for a clean identification, but close enough to reveal what matters. Someone is watching. Maybe a low-flying drone, maybe a small surveillance craft. Either way, the timing of the signal lines up almost perfectly with the destroyer's slowed position inside the channel. Iran does not simply know the field is working. Iran knows where the Americans are inside it. At 0608, the mine warfare officer gives the captain the entire problem in one sentence. This lane is not open water. It is a funnel. That changes the room. What looked like the only path through now looks like the most dangerous section of the entire grid. The corridor is not there to let ships pass freely. It is there to make them pass exactly where the designer wants them. Slow, compressed, predictable, and committed before they can turn cleanly. The captain looks at the tactical screen, then at the projected route beyond it. Dense clusters on both sides. False freedom through the center. Choke points ahead. Pressure from the ships behind. Pressure from the mines ahead. Not chaos. Control. At 0610, the drone pings another line of contacts just beyond the visible corridor. The spacing is tighter now. Cleaner. More deliberate. Like the closing teeth of a machine. And for the first time that morning, everyone on board understands the real danger. The U.S. Navy has not reached the center of the minefield yet. It has only reached the part Iran wanted them to see. At 0611 local time, the control zone begins to take shape. Not on the surface, not through smoke or flames, on a tactical screen. Inside CIC, the mine plot no longer looks like a simple defensive belt. It looks like architecture. Dense anchor points off both flanks. Layered influence triggers beneath the center line. Narrow channels that seem open until they bend just enough to steal a ship's turning room. What the U.S. formation first treated as a difficult transit lane now reads as something far more intentional. A funnel. And a funnel has only one purpose. It forces movement into someone else's geometry. The lead destroyer holds 5 knots, bow steady, wake almost unnaturally small. Ahead of it, the unmanned surface drone keeps crawling into the corridor, feeding sonar returns back one clean line at a time. Every few seconds, the data adds another piece to the same grim conclusion. The center passage is real, but only in the most technical sense. It is not safe water. It is managed water. Water shaped to keep a large combatant moving just long enough, just straight enough, and just predictably enough to become exposed. On the bridge, no one speaks unless they have to. The captain studies the range marks and asks the only question that matters. How much room do I have if I need to turn hard? The answer comes back fast. Not enough, sir. That is the moment the problem changes. Until now, the danger was an underwater impact, a disabled hull, a ship stopped in the middle of restricted water. But a disabled ship is only one kind of defeat. A trapped ship is worse. A trapped formation is worst of all. At 0614, the drone enters the narrowest part of the visible corridor. Its sonar begins painting heavier objects farther ahead, deeper and more evenly spaced than the earlier belts. These are not the loose edges of a field. These are internal control points. The places where a capital ship or destroyer-sized hull would lose the space to maneuver cleanly without exposing itself to the flanks. One officer overlays the probable turning radius for the ships behind them. The result appears immediately, and it is harsh. If the lead ship pushes deeper, the vessels astern will be committed before anyone can undo the geometry. If it stops too long, the column compresses. If it tries to back out, it does so blind, into water that is already restricted. The mine warfare officer does not soften it. Another 1,000 yards, and we are inside the box. At 0616, the first surface complication appears. Long-range radar picks up multiple fast contacts at the edge of detection. Small, low, intermittent in sea clutter. Not close enough for certainty. Not close enough for a clean identification. But their spacing is wrong for fishing traffic and far too coordinated to feel accidental. Electro-optical zoom confirms wakes. At least 4, maybe more. Running parallel, not closing in, watching. That is what makes it worse. They are not engaging the formation. Not yet. They do not need to. Their presence alone forces the American crews to divide their attention between the sea above and the danger below. Every watchstander in CIC now has 2 battles to follow at once. One visible, one hidden, one moving, one waiting. And that is exactly how a trap works. It forces you to defend in 2 directions while giving you nowhere to go. At 0618, the MH-60 tightens its orbit overhead. Its sensors sweep across the fast surface contacts, then return to the mine corridor below. The helicopter crew is not trying to chase anything right now. Their job is to preserve the picture. Because the last thing anyone wants is to open one narrow path through the field, only to discover that the surrounding approach lanes are being watched by surface craft or coastal observers feeding information farther inland. Then the underwater picture gets worse again. The unmanned craft sends back a fresh cluster of returns, this time directly beneath what had looked like the cleanest stretch of the center passage. Influence signatures, not moored spheres. Something more advanced than that. Larger casings set lower in the water column, almost certainly designed to respond to pressure changes, magnetic fields, or acoustic profiles. The kind of underwater devices that do not need a ship to touch them. They only need the ship to pass close enough. One of the younger operators mutters it under his breath. They built a false lane. No one corrects him because he is right. The corridor was never meant to be trusted. It was meant to be chosen. At 0621, a sudden pressure wave rolls across the forward drone feed. Not a major detonation, not a direct contact, but close enough to distort the camera and send static through the telemetry. The drone lurches, stabilizes, then loses one of its forward sensors. Something in the field has either shifted, reacted to nearby pressure, or responded to the earlier clearance attempt farther back. Whatever the cause, the message is clear. These are not isolated pieces of hardware. They interact. Pressure, proximity, and underwater shock may be linked across different sections of the field. The captain hears the report and gives one order: freeze. No ship advances, no ship turns, no ship tries to improvise. For 10 seconds, a U.S. Navy formation sits at the mouth of a mine funnel, while the morning sea remains calm enough to make the danger feel almost unreal. Then intelligence fusion inside CIC pulls the entire picture together. The layered belts, the false corridor, the shrinking turn radius, the surface contacts holding outside close range, the internal control points placed exactly where larger hulls would lose freedom of movement. This was never about stopping the first American ship that entered the field. It was about fixing the formation in place. Let the mines take away mobility. Let the trapped water do the rest. At 0624, the mine warfare officer leans over the tactical display and traces a line through the corridor with one finger. If they can hold us here, he says, they do not need perfect long-range shots. They just need time. That lands harder than anything so far, because now the minefield is no longer just an obstacle to clear. It is a battle space shaped for whatever comes next. Fast boats, coastal systems, aerial platforms, maybe submarines waiting beyond the lane. Maybe nothing immediate at all. Just enough pressure to keep the formation pinned while its options disappear one by one. On the bridge, the captain looks at the screen, then out over the water, then back down again. He does not order a breakout. He does not order a retreat. He gives an order colder than either. Rebuild the field. Find the logic. And just like that, the U.S. Navy stops trying to push through the trap. It starts preparing to turn it. At 0625 local time, the destroyer stops treating the minefield like clutter and starts treating it like doctrine. Inside CIC, the tactical display is no longer just a board of threats. It is a blueprint. Red marks are grouped by depth, trigger type, and spacing. The mine warfare officer stands over the plot with 2 sonar specialists and an explosive ordnance technician. They are no longer asking where the next safe lane might be. They are asking a harder question. What keeps this entire field working? That shift changes everything. Up to this point, every instinct has pushed toward clearance in the usual sense. Find one mine. Neutralize one mine. Move forward a few hundred yards. Repeat. But this field is too large, too layered, and too intelligently arranged for that. Clear it one object at a time, and the formation will still be sitting here when the next phase of the trap arrives. The captain does not want the surface cleaned. He wants the structure broken. At 0627, the first pattern appears. The densest mine clusters are not actually the most important ones. Those are the walls. What matters more are the hinge points, the smaller pockets placed exactly where a ship's natural reaction would be to adjust course, add power, or widen its turn. Those pockets hold the geometry together. Remove enough of them in the right sequence, and the false corridor begins to lose its shape. The field stops guiding. The trap stops steering. One of the sonar operators circles 3 nodes on the plot. These are not here to stop us first, he says. They are here to keep us committed. That is the center of it. The corridor ahead is not a passage. It is a behavior channel, a pressure funnel, a place designed to make large ships choose predictably, then keep choosing until they are too deep to back out cleanly. Break the hinge points and the funnel becomes just another dangerous patch of water. Still hazardous, still unforgiving, but no longer controlled by the side that placed it. At 0630, the MH-60 shifts from surveillance to marking support. Flying low and disciplined over the outer edge of the field, the helicopter crew begins laying reference points tied to real-time drone sonar returns. No flares, no show of force, just tight turns, exact coordinates, and a live picture feeding straight back to the destroyer. Below, the unmanned surface craft moves sideways instead of forward for the first time that morning, tracing the edge of one hinge cluster and confirming what CIC now suspects. The trigger network is asymmetrical. The field was designed around how an American formation was expected to enter, not around how the side that placed it might need to move through it later. That means the map in Iranian hands is only useful as long as the geometry stays intact. At 0633, the explosive ordnance team carries out the first control disruption. Not the largest node, not the closest one, the right one. A small charge is guided into position against a mine sitting just off the apparent center line of the false lane. The drone pulls back. The sea rises with a dull underwater concussion. White water lifts, folds, and collapses. Sonar clears. For 3 seconds, the picture looks more confusing. Then it becomes clearer. The line of usable water ahead is no longer centered. The corridor has shifted. A secondary cluster lights up to port, exposed by the changed pressure pattern and stripped of the illusion that had hidden it before. The false lane is beginning to lose its shape. No one on board celebrates. They are too busy watching the trap deform in real time. At 06:35, a second disruption charge goes out. This time, it is placed against one of the deeper influence mines anchoring the inner bend of the funnel. The effect is immediate. Several neighboring signatures waver on sonar, as if the assumptions behind their placement have just been broken by the pressure wave. Not destroyed, dislocated in tactical value. And that is enough. The captain leans toward the plot. Again. The next 15 minutes are not loud. They are precise. 3 more controlled disruptions, 2 along the inner hinge. 1 against a staggered control point that had forced any deep draft vessel to hold its turn half a second longer than normal. Each event does less physical damage than a major strike, but more tactical damage than Iran can afford. Bit by bit, the false corridor unravels. The clean central path becomes visibly unreliable. The mine belts still exist, but the logic that made them function as a shepherding tool is coming apart. At 06:41, the fast surface contacts outside the field change behavior. Radar shows one of them slowing abruptly. Another turns away from the zone it had been pacing. Long-range optics catch a short burst of spray as a boat cuts throttle harder than expected. Like a helmsman suddenly no longer trusts the water ahead. They are not leaving because they are being chased. They are leaving because the lane they expected to exploit no longer belongs to them. Iran placed 6,000 mines to manage American movement. Now the Americans are using those same waters to deny Iranian confidence. That is the reversal. The US Navy does not need to clear the whole field to win the moment. It only needs to break the designer's control over it. Once the original geometry becomes unreliable, every fast boat, support craft, and observer on the Iranian side has a new problem. They can no longer be sure where the safe approaches are. They can no longer count on American ships being held exactly where planned. The trap has not disappeared. It has changed owners. At 06:44, CIC identifies a narrow lane opening along the outer edge of what had previously looked too dense to trust. Not a gift. Not a miracle. A route created by tearing apart the assumptions that held the funnel together. It is thinner than anyone would like, but unlike the corridor ahead, it is not serving someone else's plan. The captain makes his decision immediately. Bring us 2 degrees port. Minimum rudder. Hold 5 knots. The helmsman repeats the order. The ship responds slowly, carefully, like a blade turning inside a lock. Above, the MH-60 shadows the movement. Ahead, the drone verifies each yard. Astern, the rest of the formation waits on the lead ship's motion. Every bridge team is watching the same truth from a different angle. For the first time that morning, the US Navy is no longer reacting inside Iran's trap. It is moving through a lane of its own making. And beyond the mine belts, the small Iranian craft that had been circling the edges now face a problem no one on their side planned for. The water they trusted is no longer trustworthy. At 06:45 local time, the first American hull begins to slip out of the trap. Not fast, not dramatically, just a few degrees of port rudder, 5 knots of careful thrust, and a billion-dollar warship easing into a lane that did not exist 30 minutes earlier. On the bridge, nobody mistakes that for safety. The minefield is still there. The belts still sit below the keel line. Influence triggers still wait in cold water on both sides. But the geometry has changed, and that matters more than speed. Ahead of the bow, the unmanned surface craft verifies each stretch of water before the destroyer takes it. 10 yards. Pause. Another 10. The MH-60 circles above with its sensors locked downward, sending live imagery and coordinates back into CIC. Every move is checked twice before steel commits once. Behind the lead ship, the rest of the formation holds exact intervals. No bunching, no panic turns, no wasted radio traffic. This is what discipline looks like when one wrong correction can open a ship to the sea. At 06:48, the new lane stabilizes. It is narrow, rough, and full of risk. But unlike the false corridor ahead, it is no longer built around Iranian control. The hinge points are broken. The shepherding pattern is gone. The mine belts still threaten the ships below the surface, but they no longer decide how those ships have to move. That single change breaks the logic of the entire setup. Inside CIC, a surface tracking operator calls out the fast contacts again. The small craft that had been pacing the outer edge of the field are no longer holding a clean parallel screen. One has dropped farther back, another is circling wide, uncertain. A third appears to test an approach angle, then gives it up almost immediately. Their problem is obvious now. The water they expected to use has become unreliable. The Americans are no longer compressed inside the intended funnel. The timing window for any follow-on pressure or targeting support is closing fast. Iran has not lost its mines. It has lost control of what those mines were supposed to make happen. At 0651, the lead destroyer clears the most dangerous bend and enters a stretch of water wide enough to regain limited maneuvering room. It is not open freedom, but it is enough. Enough to turn, enough to build speed if forced, enough to stop being a fixed answer to someone else's tactical question. That moment lands across the formation. A cruiser astern updates its projected route and confirms alignment with the same lane. Another destroyer shifts half a degree to match the lead ship's cleared track. The column is not escaping blindly. It is being drawn through verified geometry, one hull at a time, through a channel created by breaking the minefield's internal logic instead of trying to erase the entire field at once. That is the real victory. Not spectacle, not one massive blast, not a cinematic last-second escape. Control. At 0655, electronic warfare reports a change in Iranian emissions. Short bursts, less regular, less confident. Whatever surveillance chain had been feeding on the U.S. formation's slow compression is now trying to rebuild its picture inside a battle space that no longer behaves as planned. The Americans are moving, but not where the original map said they would. The corridor that looks safe is now tactically useless. The outer approaches Iranian craft may have trusted are now suspect. A field placed to hold the U.S. Navy in position has become a field that complicates Iranian movement as much as American transit. That is the trap turning inward. At 0658, the captain receives confirmation that the second major hull in line has entered the new lane successfully. He gives no speech. He does not need one. Maintain sequence. No deviations. The words are plain, but every sailor on board understands what they mean. Keep the spacing. Keep the discipline. Do not give the other side another variable to exploit. The destroyer's wake grows slightly longer as speed inches up, just enough to preserve steerage with a little more confidence than before. Overhead, the helicopter widens its orbit. Astern, the formation begins to stretch back into something recognizable as naval order rather than compressed survival. At 0703, the mine warfare officer delivers the assessment the whole morning has been building toward. Transit restored, control geometry broken. That is the line. Not minefield cleared, not opposition defeated, not area secured. Control geometry broken, because that is what actually happened here. Iran placed thousands of underwater mines, not simply to stop the first American ship on contact, but to shape a decision tree. Slow the formation, funnel it inward, strip away room to turn. Hold it long enough for the next layer of pressure to matter. Fast boats, drones, long-range coastal systems, maybe submarines, maybe only intimidation. It did not matter which came next. The minefield's job was to make all of them easier. Instead, the U.S. Navy read the field for what it was, found the hinge points, and pulled the design apart from inside. By 0707, the last of the immediate box pressure is gone. The formation is not fully free yet, but it is no longer trapped inside the geometry Iran built. And that means the operational failure on the Iranian side is deeper than a few lost mine nodes. They have exposed their method, their placement logic, their preferred choke angles, their assumptions about American movement under pressure. 6,000 mines were supposed to hide those answers beneath the water. Instead, they revealed them. The sea ahead opens by degrees, not miles. The first destroyer moves into cleaner water. The second follows. The others align behind it. No cheers. No dramatic release. Just the cold professionalism of sailors who know how close they came to being fixed in dangerous water and know exactly why they were not. Iran thought 6,000 underwater mines would corner the U.S. Instead, the U.S. turned the entire field into the worst trap Iran had built for itself.